When you are given something like this, it doesn't make any sense to write it that way. It would make more sense to write it in what is called exponential form. Exponential form. So say take 4 to the 6th power, which I know Philip's going to figure out what that is right now. You would write it this way. If you had it this way, you would write it that way. Okay? This is exponential form. Okay? Or take z this way, exponential form. That is the base with the number of times it's being repeat multiplied. Okay? You can even consider, what is the number anyway? 4,096, okay. You can even consider 6 times z times 2 times z times z. And take this and put it in exponential form. First multiplying the numbers, but then taking the z and powering it to the 3rd power for the 3 z's implied here, here, and here. Okay? That's basically what example 1 is showing us. And what example 2 is showing us is how when you are faced with a, perhaps a rectangle, and you are given some data about it. This is, remember, these are not out of the book. I don't regurgitate the book at you. If I said to you, tell me what the area is of this rectangle based on the data you've been given. Stay with me. You know that area is equivalent to length times width, right? Everybody with me? Everybody's taking notes? Well, length times width is going to be the product of 2y and 5y, which most of you can see is 10y squared, but if you don't see that, you can distribute, or I'm sorry, you can associate, commute and associate your numbers. If you need to do that. If you can do it mentally, that's fine too. The area of this shape is 10y squared, which to you and me means nothing real, but it is usable. You certainly aren't going to buy 10y square feet of something, square feet of something. Now, some of the rules that end up getting associated with exponents, we're going to get to those in a second. I'm going to just show you one more small example. Evaluate if. I'm going to show you the next one, and then I've got to get into some rules. I want you to evaluate the following two things if the variable m is equal to -2. M is equal to -2. Okay, what are we evaluating? Well, we're going to do the first one, which is 4m cubed, and the second one, which is the product of 4 and m raised to the 3rd power. These are two very different things, because for this one, only m is being cubed. The m is the only thing that takes the cube. So it would look like this: 4 times whatever -2 cubed is. Giving you 2 times 2 is 4 times 2 is 8. 4 times -8, right? So for that one, you end up with a negative 32. Okay, when an exponent follows something without a bunch of parentheses, it only affects the preceding something. In this case, variable. In contrast, 4m are being cubed because of the parentheses. The parentheses instructs us that this is a unified unit, both being affected by the cube. So you take your 4, multiply it by a negative 2, because that's what m is, and that result gets cubed. Do you guys see the difference there? When it is a parentheses issue, the cube affects the entire thing. When not, it only affects that. Which brings you to negative 8 being cubed. Completely different number. This becomes extremely important in the lessons to come. You will be asked this versus this, and more often than not, you will have different answers. So moving on into rules, and that'll get us into examples 4, 5, and 6. Order of operations, what we're adding to the conversation is exponents, powers, roots, that kind of thing. And that's the example, or the second item over there. Always do parentheses first, which we did here. Then comes exponents. The order of operations is what dictated that. And example 4 is going to allow us to use that. So here are 4 different items or so that we're going to fool with here for just a second. And I'm going to write them out for you. Here's the first one. It's a negative 3 cubed. Second one is negative 3. Actually, you know what I'm going to do? I'm going to do it to the 4th power. And I'll do this one to the 4th power. And here's example D. Okay, so I have this and this that look extremely similar. Shoot, that's right out of the book. I copied these. Goofball. This here is extremely tricky. You might be saying, well, that means you do the negative 3 multiplied by itself 4 times. That's not actually true. This means the opposite of whatever 3 is multiplied by itself 4 times. Again, the exponent only affects the thing it precedes, or it follows. It follows a 3. It follows a negative 3, Mrs. Myers. Yes, but the negative is separate, which is why you break it up this way. In contrast, here, they are forcing us to keep the negative attached to the 4. To the 3. Giving us a positive 81 as a result. Last couple of things. Adding together what's in parentheses first, and then cubing it. Gives you that. Whereas here, the exponent only affects the thing it follows. And then the 1 gets added to it. Okay, the trickiest one of the entire bunch is this. This is the one that year after year I continue to see issues with. Okay? This kind of a problem. Watch out for a negative number being raised to a certain power. Pull the negative out of it, power up the number, and reattach the letter. Reattach the negative symbol. Example 5 and 6. We're doing some more evaluating, and I know we're getting to the bottom here. We're doing some more evaluating. Evaluate, and here's the example I have for you. 3r added to 2s squared, and r, I will make it 2, and s, I will make it a -4. You've already done this. You've evaluated this with these before. You've simply never thought about then taking that result and raising it to a power or squaring it as it is here. So 3 multiplied by 2 added to 2 multiplied by -4 is going to be squared. Okay, we're going to square that. After you find the sum, we plugged in our r, we plugged in our s, so that's a 6 and a -6 and a -8. The -2 is what is going to get squared. Okay, notice it is still in parentheses. That's why you get a +4. Okay, again, don't look at that one when you're looking at this. This is in parentheses, ergo the negative symbol stays with the number. In contrast, this one is not. Example 6 is the exact same thing, only we are simplifying something on the top, something on the bottom, and then simplifying from there. I'll let you guys take a quick gander at example 6. And when you feel comfortable, you can go ahead and get started with 10 through 40 evens on 143, 144.